Hello ladies and gentlemen, and welcome back. In this video we are going to learn about the 555 timer. So in this section it's going to be about the 555 timer and the different operating modes for the 555 timer. But before going into details, what we need to learn about is how the 555 timer works, the internal architecture of the 555 timer, what are the different pins and what they do. Alright, so if we take a look here, right, the 555 timer, we can see that it contains here a voltage divider, two comparators, so comparator number 1, comparator number 2, a flip-flop, and an output drive. As simple as that. So the voltage divider here, we can see that pin 1 and pin 8, right? Pin 1 is connected to ground, pin 8 is connected to VCC, which is basically voltage input. Now the voltage input for the 555 timer should be between 5 and 15 volts. All right. Now the voltage divider contains three resistors. All of them are 5K. So the voltage divider at between R1 and R2. So let's give them some names here to make life easier. R2 and R3. So the output voltage between R1 and R2 is 2/3 of the input VCC. So for example, if the input VCC is, let's say, 9 volts, all right, so 9 volts times 2/3 equals to 6 volts, right? All right. And between R2 and R3, it's third of the VCC. So basically, if the input voltage is 9 volts, it is 3 volts. Here, the output is 3 volts. All right. Now let's go to comparator number 1. As you can see here, this third of the VCC is connected to the positive input of the non-inverting input of this first comparator, and the negative or the inverting input is connected to pin number 2, which is called the trigger. Now, if the voltage, now as you know, a comparator works by comparing two voltages, right? Two analog voltages together. Now, if the voltage at the positive side is greater than the voltage at the negative side, right? So for example, here we have 3 volts. Let's assume that. And let's assume that trigger 2 is connected to maybe 5 volts, right? Then what is 5 volts? Since 5 volts is greater than 3 volts, the output will be 0. But if the voltage here is maybe 1 volt, then the output will be 1, right? Because 3 volt is greater than 1 volt, the output will be 1, right? So basically, it's either the output of a comparator is either 0, so 0, low, or 1, which is high, all right? Only two possible values, all right? And for comparator number 2, the inverting side is connected to 2/3, and the positive side is connected to threshold, right? And we'll talk about that later on. So both of these comparators, they output either 0 or 1, and this outputs either 0 or 1. And both of these go to a flip-flop. Now, if you don't know what is a flip-flop is basically a circuit that converts low to high or high to low. So if we have 0 as output of comparator number 1, the output here, so here we'll have Q bar, this is output number 1, and this will call it Q, all right? So if we have output here 0, the output from the flip-flop will be 1. And if the input from the comparator to the flip-flop is 1, the output will be 0, right? And the same goes here. All right, dear students. Now this flip-flop, all right, Q1, as you can see, is connected to pin number 4, which is responsible for resetting the flip-flop state. All right, we'll talk about that later on. Don't worry about that. But I'm trying to keep things as simple as possible here. But for Q bar here, let's call this Q bar, is connected to the output drive. So if the output of the flip-flop is 1, right, the output of drive will be 0, right? And if the input, if the output is 0, right, then the output will be 1. So we'll have some output from this output drive. Now, as you can see, we have all these different pins. As I said, ground and VCC, these are connecting to ground. This is connecting to voltage input. This is for discharging, so number 7. Threshold, so as you can see here, threshold is connected to converter number 2. So what we can do, since we have here 2/3 of VCC to the non-inverting, we can control the output of this converter throughout controlling the voltage going through pin number 6, which is threshold. If we have 6 volts going to the negative side here, to the non-inverting side, sorry, to the inverting side, we can control the voltage here. So if we make the threshold voltage maybe 7 volts, so the output will be 1. But if we make it maybe any value that is less than 6, since we have 2/3 VCC is 6 volts, right? The output will be from here is 0, right? Not 1, it will be 0. All right. Now control voltage. As you can see here, we say that this is 2/3 VCC going through the inverting sorry for that, going through the inverting side of the converter. What if we want more than 2/3? Can we do that? Yes, we can through the control voltage. We can apply some voltage here, making this instead of 6 volts, maybe 7 volts, 5 volts, however value we want. All right. For the reset, as I mentioned earlier, that the reset resets the state of the flip-flop. 3 is the output of this 555 timer. Trigger is what triggers the 555 timer to work from the first place. So, as you can see here, we said earlier that this is connected to 3rd VCC. And we said that if we apply a 5 volt voltage here, the output, right, 5 volt is greater than 3 volt, then what the output will be? It will be 0, right? Then through the flip-flop, since this is 0, right, the flip-flop output will be 1. And because when we send a high signal, right, through the output drive, the output from the 555 timer will be 0, right? So if we want an output from the 555 timer, the trigger voltage, right, should be low, right? So a negative pulse, or basically maybe sending any voltage value that is less than 3 volts, right? I hope this explains the 555 timer and how it works, right? As simple as I could. Now, in the next video, we'll talk about the different modes we can operate this 555 timer. All right. Thank you very much for watching. I will see you in the next video.